All right, I'm glad you decided to take a look at this video about all of the formulas in your textbook. I'm starting on page 66 and I'm going right through every one of those formulas for geometry. So if you don't need any help except on sphere, then you can just skip to the end of this recording right to spheres. Won't hurt my feelings at all. But if you do need help, you are more than welcome to pause on a different page and go through the problems with me. I'm giving you a sample problem on every single formula. So some of you are great at formulas and this isn't a big deal, and some of you are like, okay, let's walk through how to use the formulas. So that's why I'm here. So here we go. The rectangle. Now, just so you're familiar in geometry, perimeter is just the outside edge. If you were to fence something in, you would not fence the entire thing down the middle. You would go right around the edge. So perimeter is just how the distance around the edges. So that's what this formula means, 2 lengths plus 2 widths. So I substitute my length, which is 15, in for L, substitute in 5, which is my width for W, and then I multiply. 2 times 15, 2 times 5, so I have 30 plus 10, which is 40. And we always label our answer, so this is in centimeters. Area, L times W, that's length times width. Okay, so I write my formula down. And you may think it's redundant to write your formula down, but I always write the formula down. It helps me keep organized. And if I stay organized in my math, I don't make mistakes. And it's just easier for me to do. So my length goes here, that's 15. My 5 goes here. Now, just so you know, when you have a letter next to another letter, in math, that means to multiply. So anytime you see letters next to each other, I just want you to know that they're asking you to multiply. So when I put the 15 in here, that means 15 times 5. So I just want to make sure that's clear. And 15 times 5 is 75, and area is always units squared. So this would be 75 units squared. All right, a parallelogram. Here we go again with perimeter. Again, perimeter, we're adding up all of the edges. So we wouldn't be adding this one in because that's the height. That's how far apart these two parallel lines are. So perimeter is I'm adding up the two sides plus the other two sides. So 2 times 6 and 2 times 16. So I have 12 plus 32. Add them up and I get 44 centimeters. So that's how much fencing, so to speak, if this was my backyard, a very small backyard sits in centimeters, I would just need 44 centimeters to go all the way around. But to find area, it's base times height. And you may be going, why is the base up here? Well, that 16 is the exact same number here because on parallelograms, opposite sides are congruent. So that just means base. Height is how far apart they are. And this box means that they're perpendicular. Height always has to be perpendicular, which means it makes a right angle, which means you can also never use a slant as a height. So my area, base times height. Again, I write my formulas down. So what's the base? 16. What's the height? 5. And when letters are next to each other, it means to multiply. So 16 times 5 is 80. And again, area is always your units are squared. All right, 2 down. We're doing good. Let's go to a trapezoid. Whew, it's getting crazy. We got 2 slanted sides. All right, did you remember perimeter means to add up all the sides? So they put all these crazy letters in here, and I'm like, all right, well, I'll write it down. But if you happen to know that perimeters add up all the sides, I just start adding up. I just start here, 10, 8, 17, 9. And do we add the 7? No, that's the height. That's how far apart these two parallel lines are, because a trapezoid has 2 parallel lines and 2 non-parallel sides. So here we go. 10 plus 9 plus 17 plus 8 gives us the grand total of 44 centimeters. All right, here's my area formula. And notice we're going to have to add a capital B plus a lowercase b. That's just how they define the bases. A base, again, are just these parallel sides. So let's substitute in. My h is 7. And when you have a fraction or a number next to a letter, again, it means to multiply. So I have half of 7 times the sum of 17 plus 10. And order of operations will tell you have to work out what's in parentheses first. And 17 plus 10, we've got 27. Again, one step at a time. Write it down line by line, step by step. Now this says area equals 1/2 times 7 times 27. And technically with multiplication, you can multiply in any order. You'll get the same answer. But for the sake of this presentation, I'm just going to go from left to right. So I'm going to do half of 7. And what's half of 7? 3.5. And then I'm going to multiply 3.5 times 27. I don't have that memorized. I know it's over 81, but you can use your calculator. So it's 94.5. And again, area always has centimeters squared. All right, trapezoid. Woohoo! Let's go to triangle. No more 4 sides. So perimeter. All they're saying is S is a side. Why? Because perimeter just means you add up all the sides. So again, sides are on the outside. What if you had a triangular shaped backyard and you need to fence in the triangular shaped backyard? You would not put a fence here. Some of you are like, well, what about the dog run? No, none of that. Okay, so let's add up all the sides. 18 plus 14 plus 10. We're just going to add them up and we get 42 centimeters. Area is different. Area is half of the base times the height. And this matters which side is your B for your base. The base and the height are perpendicular to each other, so the height has to touch the base. So that's how you'll know which number to use. It's where the height, again, it touches the base. See the box? It's perpendicular, it makes a right angle. So I'm going to substitute in half times base, which is 10. Height is 12. Half of 10 is, we'll just go left to right, half of 10 is 5. 5 times 12 is 60. And again, it's centimeters squared, or your units are squared. All right, so let's take a break from perimeter and from area. And let's talk about the angles in a triangle. The angles of a triangle are pretty unique because if you add up all 3 angles, add up angle 1, angle 2, angle 3, or angle A, angle B, and angle C, they will always add up to 180 degrees 100% of the time. Every triangle out there, whether it's scalene, isosceles, equilateral, if it's a right triangle or a acute triangle or an obtuse triangle, doesn't matter. That all the angles will add up to 180. So my problem I'm giving you here is I gave you a triangle and I need to find the missing angle. So I've got the missing angle and a 36 and a 73. So I write down my formula, A, B, and C, and just substitute in. And I just picked which one was B and which one was C. It didn't matter. But how do I solve it? Well, in order to solve an equation, because there's an equal sign, first I'm going to add my 36 and 73 together. And that gives me 109. Now my job is to get A alone because my job is to find what is the measure of angle A. So I'm going to subtract the 109 from this side, so that way A will be alone. But to keep the equation balanced, you subtract it also from the other side, from the 180. And 180 minus 109 is 71. And now you can check. If you put a 71 in here, and with your calculator did 71 plus 36 plus 73, it's going to equal 180. So you know you are correct. Ding, 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 ding. Way to go. Way to go, triangles. This is so much fun. Now let's get to one of our 3-dimensional shapes. We are now on page 68 of your textbook. Rectangular solids. So this is just a 3D shape. It's like a present. A box present. Of course, we didn't use a gift bag, although we could have a rectangular solid be a gift bag. Let's look at the surface area formula. Surface area says 2 times length times width. Remember, that all means multiply, multiply, multiply. And then I have to add 2 width times height. Then I'm going to add 2 length times height. Now, this formula may seem overwhelming because there's a lot of letters and it's long, but write it down. And then just take your time and substitute in. So here we go. What is the length? I'm going to put in 15. Right here for L. What's the width? I'm going to put in 5. So I have 2 times 15 times 5. Now write down your plus sign. 2 times, what's my width? 5 times height. What's the height? 10. Write it down. Plus 2 times the length, that's 15, times the height, 10. That's what you do. It looks long, but we're just going to take it step by step. And that's really all you do. If you stay organized, it's not as bad as it looks. Because I know you can do 2 times 15 in your head, and that's 30. And 30 times 5, that's like 3 times 5, which is 15, and add a 0. So that's 150. Go to the next one. 2 times 5 is what? 10. 10 times 10 is 100. Go to the next one. Oh, 2 times 15. We just did that a minute ago. It's 30. And 30 times 10? It's 300. There you go. 150 plus 100 plus 300. Let's just add it up. 150 plus 100, 250. 250 plus 300, we have 550 centimeters squared. And surface area is if this was a present and we were going to wrap it. How much wrapping paper would cover this side and this side and this side, and the sides I can't see because I can't turn my box around to show you right now since it's on a screen. All right, our very first volume problem. Volume is only available on three-dimensional shapes. The volume is the air inside the box, or if I were going to put jelly beans inside the box or something, how much space is inside that I can fill up. And the formula for volume is length times width times height. So here we go. What was the length? 15. What's the width? 5. What's the height? 10. And what does it mean when you have letters next to letters? Multiply. So here we go, and I know you memorized 15 times 5. 15 times 5 is 75 times 10, 750 centimeters. Ooh, a 3 here. So volume is always cubed. It's cubic units because you're doing centimeters times centimeters times centimeters, and how many sets of centimeters were there? 3. You did good. All right. That's it for rectangular stuff. Now we're going to go into circles. This is where you're going to start seeing pi all over the place. So here we go, our first circle. Circle, circle, circle. And from the center of a circle to the side is a radius. And if I went from one side, hit the center, and went all the way to the other side, it'd be a diameter, and that's okay. The first thing we're going to look at is circumference. Circumference is if I walked all the way around the edge of the circle. It's just like perimeter, but it's with a circle. I don't know why we just can't call it perimeter of a circle, but perimeter says add up all the sides. Circumference circles, we don't have any sides. So here's our formula, 2 pi r. Okay, when you have a number next to a pi, that means multiply. When you have a pi next to a letter, it means to multiply. So let's substitute in 2 times pi times, and what's our r? What's our radius? 8. So I have 2 times pi times 8. Now, multiplication is commutative. It uses the commutative property, which means I can multiply in any order as long as I multiply everybody. And I'm going to tell you right now, I'm doing 2 times 8 because that's 16. Then I'm going to multiply by pi. So on your calculator, you do 16 times and then hit the button for pi, because pi is an irrational number, which means it goes on forever and ever and ever. And let me tell you, I have not memorized all the digits to pi. Absolutely not. But there are some people out there who do memorize that and they think it's fun, and I know there's a song for it. So if you're interested, Google, the pi song, and you can go memorize all the digits too. And then we'll all go, wow, you're different. So I just wrote down the first few digits of 16 times pi, and I just put directions here and I said round to the hundredths place. So here's the tenths, the hundredths, and now here's a 5. 5 means you go up. So if it's 5 or higher, you go up. So that 6 becomes a 7. So 50.27 centimeters. Because I'm just going around the edge, going around the edge, going around the edge, and it takes 50.27 centimeters. So if I were to take a string and wrap it around a circle that had a radius of 8, it would take 50.27 centimeters. Okay, area. Pi radius squared. You did exponents last week, so exponents are a breeze now. So when we substitute in that 8, before you can multiply by pi, order of operations says you have to do exponents first. So 8 times 8 is 64. Now just 64 times pi, again use the button on your calculator and you'll get a really long decimal, and we're rounding to the hundredths place. 1 is less than 5, so that means 6 stays the same. So we're at 201.06 centimeters squared because area is always squared. All right, now we got to go 3D with circles. This is where it gets tough. Well, I guess it's not tough. It just gets longer. La 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 la. Do you need to take a break? I probably do. Okay, a cylinder. We have 2 measurements here. We have a circle at the top of our cylinder, and if we could flip our cylinder over, you'd see a circle at the bottom. And then we have the distance between those 2 circles called the height. The first thing we're going to find is the lateral surface area. So if this was a tin can, this would be the outside of the tin can, the part that you would just wrap around in the circle. Oh, here's a better one. If you took the tube off of the roll of paper towels, the tube is just made up of this round part. There's no ends at the top. That's what lateral surface area wants. It wants that cardboard tube. So lateral surface area is 2 times pi times radius times height. I think you're getting good at knowing that that just means multiply, 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 multiply. So let's plug it in. 2 times pi times 4 times 20. And remember, You can multiply in any order you want. I'm just going to do my numbers first. 2 times 4, 8. 8 times 20, 160. And then I hit the pi button on my calculator. I only want to see all those crazy decimals once, if it's at all possible. And 160 times pi gives me a long old decimal. And I again put the note, let's round to the hundredths place, and the 4 will tell the 5 to stay the same. So 502.65 centimeters squared. It is area squared. So what's the difference between lateral surface area and surface area? This should be like total surface area. It basically takes your answer here and adds the circle on the top and the circle on the bottom. And so that's what this is. Do you recognize this part of the formula? 2 pi RH. Where did we get that? 2 pi RH. Yeah, it's the outside. That's the cardboard tube. Now we have to put the ends on the top. There's 2 tops, or top and a bottom. That's why I have 2 circles, pi r squared. So let's substitute in. We already know 2 pi 420 plus, now we have 2 pi 4 squared. So order of operations tells us you have to do your exponents first, and you know 4 times 4 is 16. Oh, looks like I skipped ahead. 16 times 2 is, that's where the 32 pi came from. And we already knew this was 160 pi. Now, I don't like hitting pi a lot on my calculator, so I want you to notice we can group these up because they both have a pi on it. I can take 160 pi and add 32 pi and get 192 pi. Hopefully I didn't blow your mind there, but we can talk about combining like terms. I think there's another video that will be coming your way later on the page that you were looking at. So now I just do 192 times pi, and we'll get a long decimal. Oh, there's a 5 in the thousandths place, so the 5 is going to tell the 8 to go up. So I'm at 603.19 centimeters squared. And again, that means if I were actually making this, I needed the product to make the outside of the tube and put a cap on the top and a cap on the bottom. That would be how much product I would need, 603.19 centimeters squared of product. All right, the volume. The volume is if I was filling this up with something, whether it's water, M&Ms, Reese's Peanut Butter Cups would be really good right now, but we can save that for later. And it's pi radius squared height. So let's substitute in. I think you're getting good. I always write down the formula. Hopefully I sound like a broken record. Either that or you've paused me a whole bunch of times so I don't sound like a broken record. And so we have pi times radius, which is 4, and we have to square it, times height, which is 20. Okay, how do you solve it? What do you do first? Okay, order of operations say you got to do your exponents first, so that's 16. So looks like I skipped ahead. 16 times 20 is 320 pi. So now I'm going to do times pi on my calculator, and I get a long decimal. Oh, look what's in my thousandths place this time, an 8. And the 8's going to tell the 0 to go up. So the volume of the cylinder is 1005.31 centimeters cubed. Yes, because we did radius times height. That would be centimeters times centimeters times centimeters. That's 3 sets of centimeters, which is why it's cubed. You're doing it. Okay, one step at a time. All right. There's only 2 formulas left. Here's the cone, the cone, the cone, the cone, the cone. Flip it over and we'll have an ice cream cone, and then we could fill it with chocolate ice cream. All right. Lateral surface area. This is the outside of the cone. So if this was really like a waffle cone, there wouldn't be this part down here where the circle is, where it has a radius of 9. It would just be the outside of the cone. It'd be hollow. That's what the lateral surface area is. The formula is pi RL. L is what we call the slant height. It's the edge of the waffle cone going down. So, or you can think of this as a hat for a birthday party. And so it's the edge of the hat, and it'd be hollow inside. All right. We need a radius, so we have pi radius slant height. So it's pi 9 times 15. Ooh, do you have 9 times 15 memorized? We know it ends in a 5 because 9 times 5 is 45. Did you get 135? All right, times pi, 3.14159 dot 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 dot. All right, here we go. So we have our tenths place, our hundredths place. We have to round to the hundredths place. So we look at the thousandths place. We could care less that there's a 6 there, but the 4 is going to tell the 1 to stay the same. So we have 424.11 centimeters squared because it's area. All right, so lateral surface area was the outside of the waffle cone, but surface area includes a lid on it, I guess you could say. or if this was a birthday party hat, a lid on the birthday party hat. I cannot think of a cone that has a lid on it, but I'm sure there's one out there and you're probably going, duh, it's this. So surface area is going to take, notice this half of the formula is pi RL. Where did we get that from? Yeah, the outside of the waffle cone. Now we have to add that one circle on the top. And how do we find the area of a circle? It's always pi radius squared. So these formulas really do come from somewhere. I did not make them up today. Let's substitute in pi radius squared. Our radius is 9, and we're going to square it. And then we've already seen pi 9 times 15. So let's start with exponents. Order of operations says you must do exponents first. So what is 9 times 9? 81. 81. So I have 81 pi, and you already know this is 135 pi, so we might as well just write it down. And like you saw in the last problem, I can add these two together. I have 81 pi's plus 135 pi's gives me 216 pi's. Now I'm going to multiply 216 times pi, and you'll get a long decimal. And we look with tenths, hundredths, thousandths. That 3 is lower than 5, so the 3 tells the 8 to stay the same. So 678.58 centimeters squared. So that's how much material you would need to actually make this cone and have it be hollow inside. One more formula there, volume. So let's fill in the cone. We got to fill it up with something. I'm going to fill it up with chocolate ice cream, maybe, have some peanut butter cups in it. I don't know. You fill it up with what you want. I got my own thing. Let's look at that formula. Oh my gosh, there's a fraction. It's 1/3. Ah! Don't worry, I got you covered. And then we do pi times radius squared times height. That's the first time we've seen height. But height is the same. It makes a right angle with the base. So we go from the vertex straight down to the center of that base, and it makes a right angle there. I guess I probably could draw in a right angle there. So that's your height. That's what that 12 was there for. So let's substitute in. 1/3 times pi times radius squared times 12. What are you going to do first? Please tell me you said exponents. Yay! 81 times 12 is 972. So 81 times 12 is 972. Now what do you do with 1/3? Now I know how much you love the unit on fractions, but multiplying by 1/3 is the same as divide by 3. Because technically we'd multiply the numerators, right? 1 times 972, and then the denominator of this is 1 times 3, so you're really just dividing by 3. So I have 324 times pi. Now if your calculator is fancy and you can do times 1/3, guess what you're going to get? 324 times pi. Now multiply by pi, and we get this lovely long answer. We have the tenths place, the hundredths place. Oh, there's my thousandths. So the thousandths place is going to tell the hundredths to do what? That 5 is going to tell the 7 to go up, go up. So we have 1017.88 centimeters cubed. Why? Because I did centimeters times centimeters times centimeters. So 3 sets of centimeters gives centimeters cubed. Oh my gosh, if you're still listening right now, you should get an award because we are on the very last formula. Yay, it's a sphere. A sphere is nothing more than a basketball, and I love basketball. I coached basketball when I taught middle school. It's a sphere. Here we go. All right, surface area. So let's just talk about a basketball. If this were a basketball, it'd be hollow on the inside. I just want to know how much stuff I need to make the basketball. That would be my surface area. The formula is 4 times pi times radius squared. Oh look, there's our radius. There's only one number when you do a sphere. I love spheres. So here we go. Let's substitute in. We have 4 times pi times radius squared. Please tell me 3 times 3. 3 times 3, 9. Now let's multiply by the 4. 9 times 4 is 36. We have 36 pi. All right, so once you hit pi, we get 113.097. Oh, that's the magic spot because we're rounding to the hundredths place. So the 7 tells the 9 to go up. What does that go up to? It goes up to 10. So we're going to end up with 113.10. And yes, you need the 0 there because if you're ever told to round to the hundredths place, you must have a value in the hundredths place. So it does make a difference to have the 0 there because it shows that you accurately rounded. And it's area, so it's centimeters squared. Okay, so let's find the volume of how much air we need to fill in our basketball. What volume? That formula is 4/3 pi r cubed. Do not stress out about 4/3. I got you covered. I got you covered. Just wait. Let's just substitute our radius in here. Okay, 4/3 pi r cubed. There's my r. Radius is 3. 3 times 3 times 3 is 27. All right, so we're going to multiply 27 times 4, then you divide by 3. Because that 4/3 is just an unfinished division problem. It's 4 divided by 3. It's 1 and 1/3. 4 times 27, you can do it on your calculator, divide by 3. And you're going to get 36 pi. Oh my gosh. Oh, that's kind of funny. That's a coincidence. It's not a mathematical error. So we already know we're going to get this answer, 113.0972 dot 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 dot. And we know to round to 113.10 centimeters cubed. You have just finished the last formula in this whole thing. Woohoo! I hope you're feeling pretty good about yourself right now, because I am feeling pretty good about you right now. You can do it. Keep up the great work in all of your math formulas. Yeah.